This is an example from our textbook on probability distributions. So this is page 90, example 5. So we're given a set of information here, which is the number of daily emergency service calls made by volunteer ambulance services or service of Walterboro, South Carolina for the last 50 days. And so each day we have the number of calls. So 0 calls we have 8 times, 1 call we have 10 times, etc. I want to convert this information to number of calls to a probability distribution. So we're going to use our calculator here to do that. So we're going to add our data into lists here. So we're going to edit, and we'll put in list 1 here. We're going to put the number of calls, so 0, 1, 2, 3, and 4. And in list 2, we're going to put the frequency of the calls, so that's 8, 10, 22, 9, and 1. And we want to find the probability, and really that's like relative frequency. So we have 50 calls altogether. We're going to clear this. We're going to use our calculator to make this calculation for us. The frequency, or the probability of getting 0 calls, is 8 out of 50. The probability of 1 call is going to be 10 out of 50. So you should be able to realize that. The calculator can do that for us. In this list, we want to take everything in list 2 and divide it by 50, and that'll calculate the likelihood of each event, or 0, 1, 2, 3, 4. Just to remind you, the probability of 5 calls here is 0. This is an exhaustive list. They either get none up to 4, nothing else. And we have talked already in class about normal distributions and binomial probability distributions. These don't apply here. This is just a regular probability distribution. So we're going to put probability here. So probability of x, where x is the number of calls, is going to be 0.16, and I'm just writing these from the calculator. 0.2 here, 0.44, 0.18, and 0.02. Of course, adding those all together will give us 1, because we're guaranteed to get one of these because it's exhaustive. So there's the answer to A. B says, is this an example of a discrete or a continuous probability distribution? This is discrete. We can count how many calls they receive each day. That makes it discrete. What is the mean number of emergency calls per day? So we're looking for the mean of this probability distribution, and so we're going to use our calculator again. We want to calculate now, so stat calculate. Mean is a 1 variable statistic. List 1 is our number of calls. Our probability is in list 3. So list is the number of calls, or the events here, and frequency, or probability of each of those, is in list 3, and we just go calculate, and we're going to see that the mean number of calls per day, or expected value here, is 1.7, and the standard deviation is 1.004 if we want to 0.5 if you want to keep all those digits. We notice our n value here is 1, which we expect because it is a probability distribution and we're guaranteed that it's one of them because it's exhaustive. And so that's the answer to that question.